we're going to do page 8, and we're going to start with here 9b. So if this binomial expansion with an unknown degree is equal to 1 minus 12x plus 60x squared minus blah, 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 find the values of k and n. Okay, so this is another one of those backwards problems where we don't know what n is. We know what a and b are, but we don't know what n is, and then they give us part of the expansion. So don't panic. So let's write down what the a and the b are. So a is 1. So a being 1, that's a little bit suspicious, right? That is a super easy a value. So like, notice they're compensating the fact that this is a difficult problem, an unfamiliar problem, by giving us an a value that's very easy, okay? All right, so how are we going to do this? We know that the first 3 terms are this. What do the first 3 terms look like from the general term formula point of view? So it would be, this is our general term formula. N chooses R, a to the n minus r, b to the r. Okay, that's what it looks like in the formula booklet. Our n value is unknown. The r value for the first term is 0, right? And of course, the a value is 1, so we could put 1 to the n minus r, but 1 to the n minus r is just 1, so we won't even write the a value, okay? It would, if we wrote it, it would be 1 to the, unknown n minus 0, but this is just 1, so we're not even going to write it. Okay. Let's look at the b value. So the b value is kx. So we're going to put kx in parentheses, and then we're going to put it to the r power. Except we know r in this case. Since this is the very first term, the r value is 0, right? The r value here is 0, the r value here is 1, the r value here is 2, okay? Because the first term is r equals 0, the second term r equals 1, etc. So this would be r equals 0. Oh, so that's 1 also. So basically, our first term is going to be n chooses 0, and n chooses 0, remember Pascal's triangle, the first number in the row is always 1, 2. So this is just 1 also. So the whole thing is just 1. So we don't need to do the general term for the first term. We know it's 1 already. Okay? Now let's do the second one. So the second one would be n chooses 1. And then it would be the a. We don't need to put the a expression because it's 1. And then we just put the b, which is kx to the 1, right? And then finally, we're going to do the third term. And the third term is n chooses 2. And then the kx is to the second power. Okay, now let's expand this out a little bit. So n chooses 1. I'm going to write it the other way because it's a little bit more compact. Times kx plus, and then here I'm going to put n chooses 2. And then I'm going to put k squared x squared. Now I'm going to match it up with what's up here. So the 1 matches with the 1. This matches with negative 12x. And then this matches with 60x squared. Okay, so from this, we could just, set equal the non-x part here. And we could set the non-x squared part here. And those two are equal to each other. We'll make a little algebra problem. By the way, what's n chooses 1? N chooses 1 is n, right? The second number in a Pascal triangle row is always just the degree, okay? So this, we could simplify this to nkx, okay? So we know that the second term is nkx, which means that the coefficient is nk, and this coefficient is negative 12. So we know that n times k is negative 12, okay? And then for the third term, n chooses 2. We don't know what n chooses 2 is, but we know that the coefficient is going to be the n chooses 2 coefficient times k squared, and that is equal to 60. Okay. Does that help a little bit? Not sure. Okay. So let's try to use these two together to solve something. So let's take n chooses 2, and then we'll use the equation for n chooses r. Remember, is equal to n factorial over r factorial times n minus r factorial. So we're going to put, instead of n chooses 2, we're going to put n factorial, and then we'll put 2 factorial, which is just 2, and then n minus 2 factorial. Okay, and and then we put k squared equals 60. Okay, and we could simplify this a little bit, right? Because if you have n factorial divided by n minus 2 factorial, isn't that just n times n minus 1 and nothing else? Right? N factorial divided by n minus 2 factorial is n times n minus 1. K squared equals 60. Okay, so we have n times n minus 1, k squared equals 120, right? Okay, now let's take let's try to get rid of our k value here. So our k value is also equal to negative 12 over n. So instead of k squared, we're going to put negative 12 over n, okay? So we'll put n times n minus 1, k squared, which is going to be negative 12 squared, which is 144, 100 positive 144, divided by n squared equals 120, okay? So now we have n minus 1, and then so the n cancels with the n squared, and then we just have n here. And now we have n minus 1 divided by n equals 120 over 144. Okay, now we can just solve this with algebra, right? We can multiply both sides by n. We could multiply both sides by 144. So that would be, do a cross multiply to get rid of the fractions here. Okay, 144n minus 144 equals 120n. And then I'm going to subtract 120n from both sides, so there'll be 24n minus 144 equals 0. And then add 144 both sides, that'll be 24n equals 144. And then and I divide both sides by 24. 144 divided by 24 is equal to 6. Okay, if you did that in the calculator, you'd see it was 6. And there is my n value. We figured that out. Now to figure out the k value, we just say k equals negative 12 over positive 6, right? Because negative 12 divided by n. So that would be k equals negative 2. So these are the two values. Now, you might say, how the heck am I ever supposed to solve this problem? Well, this is probably, if this was on the exam, one of the problems that they're used to figure out who gets a 7, right? So you don't have to get all the points on this. What you want to do is get most of the points. So how do you get most of the points? Well, you're going to write down the general term formula. You're going to start expanding it out as much as you can. You're going to substitute in the a value, the b value. You're going to try to substitute in simpler values for n chooses 1 and n chooses 2. And then the rest of it's just algebra, right? So, but if you get this pretty much this far, then you've gotten, probably more than half the points, okay? So that is one of the most difficult problems in the problem set, and there are problems like this on the exam occasionally. So if you get that, then that would be a problem to see who gets a 7. Okay, so we're going to do number 10 of page 8. And this is a problem which can be solved using the algebra method and the non-algebra method. In this video, we're going to do the non-algebra method. So what we're going to do is we're going to look for the term which has x to the 11th in it. And we know that that term has 15 as a coefficient. So we're going to look to see what a would be to make 15 as a coefficient, okay? So this is kind of a backwards problem where they force you to do a little bit of algebra. Okay, so first thing we're going to do, I just copied the problem down here. What we're looking for is 15x to the 11th as a term. So basically the first thing we're going to do is similar to the other problems where we did the non-algebra method. I'm going to expand this, but I'm not going to expand it completely. I'm just going to try to see which of these terms actually has x to the 11th in it, okay? So remember that the Pascal's triangle coefficient goes here. So it would be 10 to the 0, 10 to the 1, 10 to the 2, 10 to the 3, 10 to the 4, 5, 6, 7, 8, 9, 10. Okay, and that's the last one, right? And then I'm not gonna, fully develop all of these because it's probably somewhere in the middle. But now I'm gonna put in the x squared part of this one and the x part of this one. I'm gonna ignore the a for now because it's not really important to find which term gives me x to the 11th because a doesn't contribute to x to the 11th, okay? So I'm gonna put x squared, x squared, x squared, put x squared for all of them. Okay, I'll stop here for now. And then 1 over x. So 1 over x, I'm ignoring the a for now because the a is not important for x to figure out which one is x to the 11th. Okay, and then I put on the exponents. The exponents are going to start with 10 and then work my way down. 8, 7, 6, 5, 4. Okay, and then the square, I start with 0 and work my way up. 3, 4, 5, 6. Okay, and let's now take a look at the x part of it to see which one of these is x to the 11th. So this one is x squared to the 10th, which is x to the 20th, divided by x to the 0, which is 1. So x to the 20th. That's too big. We want x to the 11th, not x to the 20th. X squared to the 9th is x to the 18th, divided by x in the denominator. So that would be x to the 17th, which is still too big. X squared to the 8th is x to the 16th, divided by x squared in the bottom. So that would be x to the 14th. We're getting closer, right? So this is x to the 20th. This is x to the 17th. This is x to the 14th. So do you see that every time we're going down by 3? 20 minus 3 is 17. 17 minus 3 is 14. If we subtract 3 one more time, it's this one. So this is our x to the 11th, right? So x squared to the 7th, let's just make sure. X squared to the 7th is x to the 14th. X cubed in the bottom, which gives us x to the 11th. Yes, we're right. So now let's fully develop this. So in the Pascal's triangle coefficient, we're going to have 10 chooses 3. In the square, we're going to have an a here. And now I think we just need to expand this out, okay? So 10 chooses 3 times x squared to the 7th, which is x to the 14th, times 1 cubed on top, which is just 1, a cubed on the bottom, and x cubed on the bottom. So as we remember, the x to the 14th of the x divided by x cubed gives us x to the 11th. 10 chooses 3. Let's see what that is in the calculator. So what would that be? Second, or math, probability, and chooses r. And we're going to put 10 chooses 3. And it's 120. Okay, so we're going to write down the 120 as 10. Instead of 10 chooses 3, we're going to write 120. And then x to the 11th comes from x to the 14th divided by x cubed, right? And the last thing we need to write is the a cubed. Okay, so we replace 10 chooses 3 with 120. We replace x to the 14th divided by x to the 3rd with x to the 11th. And then we're just going to write the a to the 11th down there. A to the 11th, a to the 3rd down there, okay? And we know that this whole thing is equal to 15x to the 11th because they told us so. Okay, now we just have an algebra problem because since x to the 11th is equal to each other, we know that this part is equal to 15. So now we just have a pretty easy algebra problem, which is 120 divided by a cubed equals 15. Let's multiply a cubed times both sides to get it out of the denominator. We'll have 15a cubed equals 120. Divide both sides by 15 to get a by itself. That would be 120 divided by 15, which is 8 on the calculator. And then we have a cubed equals 8. We know that 2 cubed is 8, so a is equal to 2. And that is our answer. So actually, this whole time, it wasn't x squared plus 1 over unknown x. to the 10th power, it was actually x squared plus 1 over 2x to the 10th power. So we knew it was, now we know it was this, okay? And if it is this, then it works out perfectly so that the x to the 11th term is 15. That's what we figured out, okay? So that was the non-algebra method of figuring that out. Yes, it is a little bit difficult. This problem is probably made to figure out who gets a 7.